Oumuamua was first spotted in 2017 as it entered our solar system. This unusual visitor was unlike anything astronomers had seen before. Its elongated shape and incredible speed immediately captured the attention of scientists worldwide. Initially, Oumuamua appeared as a faint point of light moving swiftly across the night sky. Calculations showed it was not bound by the sun's gravity, confirming it as the first known interstellar object to pass through our celestial neighborhood. Measuring about 400 meters in length, its cigar-like form defied expectations of what a space rock should look like. Most asteroids and comets in our solar system tend to be roughly spherical or irregularly shaped. Yet Oumuamua's needle-like appearance suggested something entirely different. Was it a shard of a shattered planet? Or perhaps a fragment of an alien spacecraft? Adding to the enigma, its trajectory was highly unusual. Oumuamua accelerated as it moved away from the sun, a behavior not typical for a mere rock. Typically, only comets exhibit such acceleration due to the sublimation of ice creating a tail. However, no tail was visible. This absence of a visible coma left astronomers puzzled. Was it composed of materials unknown to us, or was there another, more exotic explanation? As researchers continued to analyze data, the object sped along its hyperbolic path, leaving behind more questions than answers. What forces or phenomena were at play, propelling this mysterious traveler on its journey through the stars? When Oumuamua first entered our solar system, its trajectory followed the path one would expect from an object governed solely by gravitational forces. However, astronomers soon noticed something curious. The object began to deviate slightly from its anticipated orbit. This was not a typical behavior for a celestial body of its kind. Unlike comets, which often display visible tails or jets that can alter their paths through the release of gas and dust, Oumuamua showed no such features. It was a mystery. Scientists were left puzzled. How could an object without apparent propulsion mechanisms shift its course so unexpectedly? Some researchers suggested that the change in trajectory might be due to non-gravitational forces. But what could these forces be? Without a visible tail or emission, conventional explanations fell short. Theories began to emerge, some more unorthodox than others. Could it be solar radiation pressure exerting its influence? Or perhaps something even more unusual? The lack of a definitive source for the propulsion only deepened the enigma surrounding Oumuamua. As scientists continued to study its path, further questions arose about the true nature of this mysterious interstellar visitor. What forces, unseen and undetected, could be acting upon it? The initial theories aimed to unravel the mystery behind Oumuamua's unexpected trajectory. Many scientists hypothesized outgassing could explain its peculiar motion. This phenomenon, common in comets, involves jets of gas and dust that can alter an object's path. Yet, as data poured in, this explanation began to unravel. Outgassing implies the presence of water, ice, or other volatile substances. Instruments were primed to detect such emissions, but they found nothing. No wisps of gas, no trailing dust. Oumuamua, it seemed, lacked the telltale features of a comet. Instead, it behaved comet-like without the physical characteristics typically associated with these icy travelers. This contradiction left astronomers confounded. How could an object change its path without the forces we normally observe? The absence of a visible coma or tail, elements expected if outgassing were the cause, deepened the enigma. Some proposed that Oumuamua might be composed of materials not yet understood, but theories remained speculative at best. As natural explanations fell short, scientists began to ponder what they might be missing. Were there unknown forces at play, or did Oumuamua contain clues about cosmic mechanics not yet discovered? The lack of concrete explanations only led to more questions. Is it possible, they wondered, that our understanding of celestial physics needs to evolve to account for such anomalies? Some proposed that Oumuamua might not be a natural object at all. Could it be an alien probe, a messenger from a distant civilization? The idea captured imaginations and sparked heated debates among experts. Leading the charge was Harvard astrophysicist Avi Loeb. He suggested that Oumuamua's unusual acceleration could be explained by solar sail technology. This technology, which uses radiation pressure from stars to propel spacecraft, is advanced yet conceivable. Loeb's hypothesis was bold and controversial, challenging traditional astronomical perspectives. While some embraced the idea as a plausible explanation, others scoffed, viewing it as sensationalist. The scientific community was divided. Could an alien civilization have sent Oumuamua on a reconnaissance mission to our solar system? The very notion opened a Pandora's box of possibilities and questions. What would it mean for humanity if we were to detect an object object of artificial origin. However, critics argued that natural explanations should be exhausted before venturing into the extraterrestrial. Was there a more mundane reason for its odd trajectory? As researchers grappled with these questions, the mystery of Oumuamua continued to deepen. What if the truth was even stranger than fiction? Our current technology faces significant challenges in observing distant objects like Oumuamua. The first hurdle is scale. These objects traverse vast distances at immense speeds, rendering them mere specks against the backdrop of the universe. Even our most powerful telescopes can struggle to capture sufficient detail as they move rapidly through the solar system. By the time Oumuamua was discovered, it was already on its way out, limiting our ability to collect more data. This fleeting encounter left scientists scrambling. They couldn't predict its arrival, nor could they prepare adequately for its study. The technological limitations become more apparent when considering tracking interstellar objects that don't adhere to predictable orbits. Unlike ordinary comets or asteroids bound by our sun's gravity, Oumuamua is seen to change its path unexpectedly. Modern observatories, designed for cataloging and monitoring more predictable solar system bodies, were caught off guard. The challenge is compounded by the need for rapid response observation capabilities which, in many cases, are still in developmental stages. Furthermore, the data we glean from these brief encounters is often incomplete. The information gap leaves room for speculation, with theories emerging faster than evidence can be gathered. In the race against time and distance, how can our technology evolve to keep up with the mysteries of interstellar visitors, and what advancements are necessary to ensure we're better prepared next time? Oumuamua's unexpected trajectory has underscored the urgent need for advanced detection and tracking systems. Current technologies struggle to keep up with its speed and erratic behavior. As a result, astronomers are calling for improvements that would allow for earlier identification and more precise tracking of similar objects in the future. These improvements could include telescopes with greater sensitivity and software that can predict the paths of fast-moving interstellar bodies more accurately. The stakes are high, as each new visitor from beyond our solar system promises to broaden our understanding of the universe. The possibility of more interstellar visitors is not just a theoretical concern. According to researchers, our solar system could be regularly traversed by objects like Oumuamua, offering opportunities for scientific study that we are currently ill-equipped to seize. The potential wealth of information latent in these travelers is immense. They could carry clues about the conditions in other star systems or even new forms of matter. Oumuamua's journey through our cosmic neighborhood has also triggered a shift in how scientists think about the feasibility of interstellar travel. If natural objects can voyage such vast distances, the idea of human-made probes doing likewise seems less far-fetched. Concepts for spacecraft propelled by solar sails or other innovative technologies are gaining traction. Could we someday send probes to other star systems, guided by the lessons learned from Oumuamua? The possibility beckons, fueled by a renewed sense of curiosity and ambition. The mystery and promise of the interstellar medium now seems just a little closer, inviting us to prepare for the next visitor who might come calling. Oumuamua remains an enigma in astronomical history. Despite extensive study, its origins and peculiar trajectory continue to puzzle astronomers. Was it an alien spacecraft, a fragment of an unknown comet, or something else entirely? The mysteries surrounding this interstellar visitor have sparked countless theories, each more intriguing than the last. New methods of exploration and observation are being developed, driven by the quest to understand such anomalies. Innovative telescopes, more sensitive than ever before, are peering deeper into the cosmos, hoping to catch another glimpse of these celestial wanderers. As we refine our search tools, Oumuamua challenges us to expand our understanding of what's possible in the universe. It serves as a catalyst for creativity, inspiring new generations of scientists to think beyond the conventional. Yet for now, the secrets of Oumuamua remain locked away, much like the object itself swiftly moving just beyond our grasp. The universe invites us to keep questioning and exploring. Subscribe for more cosmic mysteries and updates.